Hello and welcome to Maths by SAS. This is my second lesson of D3 chapter number 1 exercise 1E, that is about the graphs of quadratic functions. This lesson is equally important for D3 students and the D2 students chapter number 5 exercise 5C, where they are supposed to sketch the graphs of quadratic functions. In my previous lesson, we learned how to sketch the graph of the quadratic functions and quadratic equations that can be easily factorized by midterm breakage or hit and trial method. And the objective of today's class is to teach my students how to sketch the graph of quadratic equation in the form y equals to x minus p whole square plus q, or y equals to minus x minus p whole square plus q. Okay, if we look at this situation given, we can see that the expression on the right hand side is written in the form a minus b whole square plus q. That indicates that the equation cannot be factorized easily by midterm breakage, and we have to apply completing square method to express that equation in perfect square form. So in this lesson we'll be learning how to sketch the graph of this type of quadratic equation. Okay, if we look at, I have drawn two situations with you. If we look at the first situation, we can see the equation is given in the form y equals to x minus p whole square plus q. Again, recall the previous lesson that for the sketching and drawing of quadratic equation and the graph of the quadratic equation, how many points are required? We need x-intercepts, we need y-intercept, okay, then we need the minimum or maximum turning point, and minimum or maximum turning point depends upon the sign of the coefficient of square term. If the sign of the coefficient of the square term is positive, then the curve will have the opening upward and it will have minimum turning point. And if the curve and the equation which is given to us as the coefficient of the square term negative, then the curve will have the opening downward and it will have maximum turning point. Now coming to first situation, we can see that the curve is not touching x-axis at all. That means that this equation will not have any real roots. And then you can see that p is the number which is used to express this equation in form of the whole square form. So the minimum turning point in this case will be p and q, and line of symmetry will be x equals to p, and then we will have the y-intercept. So in this case we require the minimum turning point, the line of symmetry, and y-intercept. Coming to the second situation, we can see that here the curve is opening downward. And why is this opening downward? Because the sign of the coefficient of the square term is negative, so the curve will have the opening downward. Again, we require two x-intercepts here, and then this is the y-intercept, and after that we have to think about the minimum or maximum turning point, as the curve will have the maximum turning point. So the maximum turning point of this equation will be p and q, okay, and the line of symmetry will be x equals to p. I hope through these sketches you are clear that how to make the sketch of the graph of the equation y equals to x minus p whole square plus q, or y equals to minus x minus p whole square plus q. Again, I'm trying to explain this procedure through 6 easy steps so that my students can keep these steps in mind while they're sketching the graph. So step 1 is similar to the step 1 of the previous case, that we have to observe the coefficient of the square term, okay, whether it is positive or negative, and after that we have to decide the opening of the graph upwards or downwards. Then we have to obtain the x-intercept of the equation, and for the purpose of obtaining x-intercept we have to put y is equal to 0 in the given equation, and we have to write 2 points. Then we have to obtain y-intercept of the equation and put x is equal to 0, and then we have to write the equation of line of symmetry, and equation of line of symmetry for the equation of the type y equals to x minus p whole square plus q will be the point which is added or subtracted over here. So x is equal to p. Okay, do observe this carefully, do not struggle, because in the previous case, when the equation can be factorized easily by hit and trial method, the equation of line of symmetry was obtained by adding both x-intercepts and making it half. But in this case, whatever will be the number added or subtracted over here, that will be the line of symmetry. And then what we have to do, we have to join this p and q to find the minimum or maximum turning point, and then we have to sketch the graph. I hope these are the two situations which you will be getting while sketching the graph of quadratic curve. I watch, understand and keep this 6-point summary in your mind to get the better sketch of the quadratic graph. Please watch my lessons, like, share and subscribe the channel and press bell icon to get the notification of every lesson in time. Thank you very much.